All right, folks. Hey, day 3. Here we go. So we got a conceptual piece on geostationary, and then we've got a concept called moment of inertia, which actually works with these fidget spinners here. Kind of interesting relationship with them as well. So we'll talk about that in a minute. Okay. Geostationary orbit. So geostationary orbit is an orbit that is kind of unique. So when we talk about geo refers to Earth. Means not moving. Now, it's a little bit of a misnomer. What you're seeing okay. What that means is that when we look at them, they are basically in the equator. When they're on the equator, they appear to be stationary, meaning that they don't move from that one location in the sky. That's because for them, their orbit is 24 hours. But really, I mean, kind of some of the stuff for us, the reason why they're kind of interesting and important to us is you're a person who subscribes to Dish Network. If you subscribe to DirecTV, use. If you've ever seen satellite dishes being installed, they're always aiming to the same location. What that means is they're all aimed south. For us, for them, that's what it is. Right? Meaning that it usually is south of us. Okay, so I've got one sitting on my roof right now. It's aimed towards the southern sky. That's because it is lining up with one of these geostationary satellites. All right. We also use it for weather. Weather is huge with this one because what we can do is we can have the infrared or the surface scan or however we want to look at it to see what is actually happening, maybe out west, right? And there's actually 2 that cover, I believe, the United States. I think this picture may be a little bit old. I don't know. I think it's like Geostar West and Geostar East, I think are the 2 that are for us. Okay. So if you were sitting on the North Pole of a planet Geo and you were watching it orbit an island and had a single island, and a geostationary satellite. So there's our island, there's our geostationary satellite. All right. What you're going to see is that it appears like that geostationary satellite is just staying in that same phase as it is, which is exactly what we want. All right. We can have that geostationary satellite just focus in on one portion of the globe, so to speak. All right. Moment of inertia. All right. Here we go. So, moment of inertia, it's defined as it's classified as the resistance to rotation. So what this means is that if you've ever tried to, say, spin a meter stick, right? Spin it around the middle point, all right? That would be creating a moment of inertia. If you've ever been on a merry-go-round and you're sitting on the outside, that would be a moment of inertia for us. If you were on ice skates and you started to get spun, that'd be a moment of inertia. All right. All of those different ones, fidget spinners, are moments of inertia. All right. So when we look at them, what we're going to see is that there's going to be a mass component to it. And then there's going to be a location of the mass in relation to the pivot point, meaning the rotation point, right? So for me, if I'm just looking real low tech at this, if I take my meter stick and I try to spin it around, meaning I try to feel like this, okay, it's going to be different than if I try to do it like this, right? And if you want to try it out, grab a ruler and try it, okay? It is very kind of interesting. So the one that I will have you do, pause it and get a heavy book, okay? Like for me, I've got our physics book. I know you didn't think these things existed, but this chapter I've had to look through it a little bit, okay? So here's what we're going to do. First and foremost, we're going to put our fingers on the bottom, and we're just going to shake it forward and backwards, all right? My thumbs are just on the back at the same spot. All I'm doing is feeling that kind of torque or that force on me. All right. Next, put it in the middle. Now see if there is a difference. Hint, hint, hint. There is. All right. The nice thing about having a heavy spined or a hardcover book is that it doesn't flip and move and stuff like that. Like I tried to do this one with it, and it kind of flaps in the wind. So it's not real great. All right. But what you should notice is that when our hands were down on the bottom, what ended up happening was I actually felt a little bit of a burn in my forearms, right? Felt a little bit of resistance there. But as we went to the middle, what happens is it seems to be very much lighter, okay? So that really helps us to understand, the farther out that object gets, if its mass is the same, the more it's going to be difficult to get that thing to move. It's going to require more resistance to motion, right? All right. So for us, formula and the math of it, okay? The moment of inertia, the variable is I. Now, I know it's weird because in the past, whenever we've talked inertia, we really haven't had a formula, okay? And like if you think of like momentum, that was P for progress. Well, similar concept here, except now we're going to use inertia, which is a capital I, all right? Units for it are kilogram meter squared. Now, make sure you got that written down. Make sure you got that in your notes somewhere. Mass is obviously one of our components. That has to be in kilograms. If I give it to you in grams, slide it 3 to the left. All right. Distance, aka radius, meaning when we're looking from where that pivot point is. So for like me here, like the distance would be all of that. Here, the distance would just be half. Okay. So it's going to be a different one there. That variable is R, and the units are meters. All right. There's your formula. Make sure you got it written down somewhere. I equals mr squared. All right. So make sure you do have that somewhere so that we can kind of utilize that one. All right. Now, there is some thought here, and I'm trying to simplify this and not make it crazy, overwhelming or anything like that. The one that we'll most often use is the hoop. All right. Meaning that when we look at this concept of a hoop, like a fidget spinner really is a hoop for us. It has all of its weight outside, at least the appreciable amount, okay? A bike tire, obviously a hoop, all right? When I go to an example here where I talk about my ruler with nickels attached to it, right? I got a nickel there and a nickel there, all right? That's essentially a hoop for us, okay? A disc is similar to this, except for the disc, when we rotate it around the middle, is going to be this infinite number of thinly spaced, basically hoops, all right? So when we talk about a solid cylinder or a solid disc on this case, what you're going to see is that we just have a different formula. Just make sure you got them both written down. We will make sure to be very, very obvious with which type we have as we run through both of those, okay? So, like I said before, I taped 2 nickels, all right? So what I've got here is, and I actually ran this with my wife this morning, and shockingly, she was not impressed. I mean, I was doing physics, trying to educate her on physics, and she just looked at me, and it became an affirmation of why I'm such a dork. God, I tell you what, some people. Anyway, no, I'm kidding. That's awesome. So for us now, what I've got is I've got my meter, I've got my Batman ruler with nickels on the outside, all right? So each nickel weighs 5 grams. First, we want to determine the moment of inertia if both nickels are placed 15 centimeters from the center of the ruler. So there's my 15 mark. That's my middle, right? I got this one out at 0 centered. I got that one out at 30 centered, okay? So what I should be able to do is I should be able to feel that. Now, I encourage you again, go show this to somebody who might be interested in it. If it's nobody, show it to your dog or your cat. They probably would love to learn physics like that, all right? So here we go. Let's determine the moment of inertia for both, all right, at both nickels. So what we've got here is we've got, oh, and I messed up this. That's right. I remember that now. All right. So what we've got is we've got actually 2 nickels. So this thing needs to be multiplied by 2 because we've got both of those there. Each of these are going to add to a moment of inertia, okay? Sorry, I forgot that. So I equals, and we're going to just put, so basically we need a double of this because we've got a nickel on each side, okay? So we've got our mass of our nickel times r of our nickel squared. All right. And the way that I want you to think about this is, and it just kind of came to me. Sorry, I know I should be better, but then I got one nickel there that's creating a moment of inertia, and one over there that's also creating a moment of inertia. Now these two, as you can see, are going to add to each other, right? Meaning that if I push this one down, this one's going to go up. Okay, so I'm going to be able to experience both of those acting in the same direction, so to speak, creating that rotation, creating that twist. So my answer here is actually 1.125 times 10 to the negative fourth times 2. It is actually 2.25 times 10 to the negative fourth. And then same units, okay? Meaning that I'll have to have, because I've got two nickels here, and they're both at the exact same spot, this will be 0.010. Sorry about that, folks. I just literally remember that from looking at everything that I was doing right there and forgot to put it. All right. So then, if we take our nickels, we move them into 5 centimeters away. So at the middle, that's 15. So if I put them at the 10 and the 20, whoa, come on now, work with me here. Sorry, live, right? So if I put them inside there, all right, and then I go to the same spot, what again I'm going to experience is something different, right? So this here would be times 2, right? Because I got 2 nickels on there. All right, again, that's going to be 0.010 because I've got 2 nickels, right? 1 and 2. All right, so then 1.25 e negative 5, 2, that'll be 2.5, right? So that'll be 2.5 times 2. So when you look at these numbers, right, they're not big. But here's the thing. Like if you actually go ahead and you put nickels or you put quarters on there, what you're going to see is there is a difference, right? This one does feel noticeably different than if I have it out on the ends, all right? Even that small, 1-0 difference makes a big difference for us in this moment of inertia, okay? So that becomes the notes for us today. Do make sure that you check out the practice that'll go up later today, and I will actually work on homework today and get that taken care of so that you have answer keys for that stuff so you can look at that and see that. All right. Otherwise, that's it, folks. Have a great, phenomenal day.